Okay, in this video we're going to do some rather unique conversions that don't require the use of the conversion table. There's going to be a little more reasoning that's going to go into this, so I'm going to encourage you to please try to organize your work. I've tried to leave space for us to do that. Okay, we're going to convert from feet to yards and feet, and this is a case where you're converting from one measure to multiple measures. So we know that we need to start with the fact that we know that there's 3 feet equal to 1 yard. And so what we can do is we can say 29 divide by 3, and we calculate that. This is pretty straightforward. This is going to come out to be like 9.6 repeating, and we don't want a decimal answer here. We want to know that we know we've got 9 yards, but this decimal 0.6 yards, we don't want that in portions of a yard, or much less decimal portions of a yard. We want that in feet. So what we need to do is we're going to recognize that we've got 9 full yards. So I'm going to write that 9 there, and I'm going to write 9 times 3 here, just so that you understand what I'm doing. 9 times 3 is equal to 27. Kind of working my division problem, or my multiplication problem backwards here. So I know that within that 9 yards, the 9 yards accounts for 27 feet. So I can subtract that 27 from 29 to know that I have 2 feet left over. So that was just one step, doing a multiple conversion. This next one, we're going to take 238 inches and decide how many yards, how many feet, and how many inches we have. So on this one, we're going to recognize that we have 36 inches equal to 1 yard. You could get that off the conversion table, but I think most of us probably know that. So we're going to go ahead and start out with 238, and I want to divide by 36. And I'm going to come up with, another 6.61. And the thing is I don't want this 0.61, 61 hundredths of the next yard. That isn't helpful. I don't want a decimal notation or a decimal portion. But I do know that I've got 6 full yards out of this. So I'm going to go ahead and write 6 full yards here. And I'm also going to write down 6 times 36. Again, there's 36 inches in each of those yards. So I'm going to say 6 times 36, which will give me 216. Again, just kind of working backwards here. And I'm going to take that 216 inches away from the 238, simply because I know that that 216 inches is accounted for in those 6 yards. So when I remove that, I get 22 inches left over. And I recognize that there's going to be 12 inches in a foot, and you probably won't even have to divide that out to know that it's going to be 1 point something or other. But we know that we've got 12 inches. I'm not even going to write what that is. But when I take 12 inches away from 22, that is my 1 foot that I can write up here. So when I take that away, I find out that I have 10 inches left over. So I have 10 inches left over. And that's something that makes common sense for us, but we probably haven't worked from that avenue. Okay, this next one, I just realized I had some typos here in my notes, so I'm hoping that I've got those fixed in your copy. That 7.5 inches, I want to put 7.5 here, and I didn't have my 1 second here. But what we're going to be doing here is speed is usually identified in a distance per unit of time. Okay? In this case, very often it's miles per hour. But in this case, we have to do a double conversion if we want to convert that to a different unit of length, different unit of distance, as well as a different unit of time. So what we're asked to do here is we're trying to convert 7.5 inches per second to feet per minute. Why would we ever have to do this? If you were in charge of a construction, the assembly line in a manufacturing firm, you might find that, some machine says that it can work on creating, so many feet of support. It can mold that so many inches per second. And you want to convert that to feet per minute, because you've got a big order that you need to figure out how much time it's going to take. So you would have to do a conversion, a double conversion like this. You're going to be converting both distance, length, from inches to feet, as well as time from seconds to minutes. So we're going to use a conversion chart over here where we are going from inches. Well, we know that there's 12 inches in a foot, so I was just starting here, but I've written it over here. I'm going to multiply 7.5 inches by the unity fraction 1 foot over 12 inches. And I did that because this is going to reduce all the way across here. And yes, you can do that. It doesn't matter what order you do your unity fractions in. You know you're going to have to do one for length and one for time. Okay, the other thing is I'm going to have to convert seconds to minutes. So I know that there are 60 seconds in a minute, so I'm going to write the unity fraction 60 seconds over 1 minute. Now I chose to put 60 seconds over 1 minute because I want these seconds units to reduce, because I'm trying to convert it from seconds to minutes. Okay, so I've got all my conversions done. I can go to my calculator and I can plug in 7.5 times 60. I guess I should write that. 7.5 times 60, and then I would divide by 12. This is how you would do this. And you end up with 37.5 feet per minute. So this is my final answer. This was just how I plugged it into the calculator. Okay, in this next problem we're going to do another type of multiple conversion here, but this time we're going from our units of measure, hours, minutes, and seconds. This is supposed to be seconds here. And I want to convert this to how many seconds. You know, back to that assembly line. Let's say you've got so many seconds that you know you need to produce something, and you know that in each shift, by the time you take out lunch and break, you know that you have the most that you can have your assembly line going would be maybe 7 hours, 22 minutes, and 18 seconds, although that seems kind of far-fetched that you're going to narrow it down to seconds. But that might be a case of when you would need to do this kind of conversion. And so I know that I need to convert, you know, my 7 hours into a number of seconds, my minutes into a number of seconds, and then add on my 18 seconds. So I'm going to take 7 hours and I'm going to multiply by 3,600. So I want to make a note over here that there are 60 seconds in every hour, or every minute, as well as 60 minutes in every hour. So I needed to multiply 60 times 60 to get this 3,600, to know that there was a total of 3,600 seconds in each hour. So that's where that came from. And so that comes out with a total of 25,200 seconds right there. Then I have 22 minutes that I know each of those minutes has 60 seconds in it, and that's a little easier for us to deal with. And so when I multiply that, I come up with 1,320, and then I have to add my 18 seconds on. When I add all that up, I'm kind of running out of space here, but I'll have 26,538 seconds. Okay. I'm hoping I got that all on there, that you can see that. Okay, moving right along, we're going to do another one of these where we're going the other direction. We've got a really large number of very small time units, seconds here, and we need to figure out how many total hours, minutes, and seconds do we have in this. So again, we're going to do what we were doing on the very first part of this video, but in terms of time. So I'm going to take 12,380, and I want to divide that by 3,600. Again, we know that there's 3,600 seconds in an hour, and that came up with 3.43. And I don't really care about that part, but I do know that 3 full hours, that there's 3 full hours I can get out of there. So when I take 3 times 3,600, I should get a total of 10,800 that I can subtract from here, because I know that 10,800 seconds is accounted for in those 3 hours. So I can subtract here, and I'll find that I have 1,580 seconds left over. And I want to divide that by 60 seconds to figure out how many minutes I've got. So when I do that, I end up with 26.3 minutes. This was hours. And I don't really care about the 0.3 part, but I do know that 26 minutes is going to go up here. And if I take 26 times 60, because I have 60 seconds in each of those minutes, I should end up with 1,560, and then I'll have my 20 seconds left over. So I can write 20 seconds here. Okay, the next thing that I want to go into, and it's kind of a very unique conversion, is board feet. Board feet is going to be used by anybody who's in construction industry. It's calculated by multiplying board thickness in inches by width and length in feet. Okay, so boards are sold by 2 by 4 by 8 feet or whatever. Now I do want to point out that we've got inches, feet, and feet is what we're looking for to create board feet. Okay, but note that boards are usually sold in thickness and width in inches, and only the length is in feet. So in other words, an 8 by 4, if you were at the store, and I know this just looks like gibberish printed here, but if you'd say it out loud, an 8-foot 2 by 4, this 2 is meaning inches, and this 4 is meaning inches. You're looking for an 8-foot long piece of wood that is 2 inches thick and 4 inches wide. That's how it's very often marketed. But in board feet, that width needs to be in feet. So that middle measure you're going to have to do a conversion on from inches to feet. So in board feet, the easiest way to do this is to represent thickness as 2 inches times 4 over 12. 4/12, that would reduce to be 1/3 of a foot. That is in feet when you just take that inches and divide by 12. And then the last term would be in board feet. So if in 8 feet length. So if I wanted to, I could go ahead and just multiply straight across here. 2 times 4 is 8 times 8 is going to give me 64/12. And if I wanted to, I could convert that. 64 divided by 12 is actually going to be, it'd help if I could run my calculator here. Divide by 12 is going to be 5.3 repeating board feet. You rarely are going to do that with just 1 foot. You're going to apply, you would need to be able to calculate board feet in terms of a shipment of many, many, many boards. So in each of these cases, we've got a shipment of quite a few boards. We've got 300 boards, 2 by 4s, and they are in 8-foot lengths. And we want to figure out how much board feet does this take up. It's just another way to express volume in this industry. So we're going to look at, and what I would tell you to do is, I think the easiest thing is just to make it one straight up multiplication and then division problem. So we're going to say 300 times 2, that's meeting our criteria of being in inches. That first one is in thickness is in inches, times we've got a width of 4, but that needs to be in terms of a foot, so I'm going to say 4 divided by 12, times our length is in feet, and that would be 8. Now rather than converting this to a fraction, I think it's easier just to go ahead to your calculator, multiply 300 times 2 times 4 times 8 and divide by 12, kind of like what I did up here. Just carry out all your multiplication and divide by 12 last. And so you should end up with about 1,600 board feet. And that's how boards lumber is usually ordered, because we express it in 2 by inches thickness and width in inches, but that usually needs to get converted to feet in terms of talking about board feet and volume. We're going to do one more. We've got a shipment of 120 4 by 4s, so these would be like landscape timbers, 4 inches by 4 inches, and these are in 12-foot lengths. So again, just set up your multiplication. It's just straight out of the plugging it all in, 4 by 4, but that second 4 is width in inches, and we need to convert it to feet. And I do that by writing it over 12 times 12. And again, you could go to your calculator and multiply it all and then divide. Or you can just say, hey, let's just reduce here. And so you're saying 4 times 4 is 16 times 120. Should give you, I believe that's 1920 board feet. So those were just some unique conversions and working with different measures, standard measures. Next we'll go on to metric.